Now, one of the first ways we have for solving a system of equations is actually to solve by graphing. It's not always the best thing for us to do because sometimes the graph doesn't show up on here or just some other inconsistencies that we may have with it. But when we talk about solving by graphing, what we're looking for is where these two equations will intersect, because where they intersect means a point that they have in common, which would be an ordered pair that would work for both of these lines. So let's see if we can figure out how we graph this first guy, x minus y equals 5. If I take this guy, x minus y equals 5, and I solve it for y, let's get the slope and the y-intercept. I move the x over, I have negative y equals negative x plus 5. Divide everything by the coefficient of y, which is negative 1. So I have that y equals a positive x minus 5. And when I do this, I can see that my slope equals 1, and my y-intercept is equal to 0, negative 5. You know what, let's go ahead and find the slope and y-intercept for the other equation as well. So for the other equation, I have this. 2x plus y equals 4. I want to get y by itself, so I move the 2x over, and I end up with y equals negative 2x plus 4. And from here, I can determine that my slope is negative 2, and my y-intercept is the ordered pair 0, 4. So let's graph each of these guys. Now for my purple line right here, my slope is 1, but I need to start at my y-intercept, 0, negative 5. So here's 0, negative 5, I got my slope of 1. So up 1, over 1, and so on. I want to have all of these points right here, which is a nice straight edge since we do have that to use. You want to make things look nice. New graph. Now remember why it is that we even draw lines. This line itself represents all solutions to the equation x minus y equals 5. Any point that you can identify on this line, you can plug the coordinates back into the original equation and it will work out. Now let's look at the other guy. 2x plus y equals 4. My y-intercept is 0, positive 4. And my slope is negative 2, which means I'm going to go down 2 and over 1. Remember, with the negative slope, you're going down as you go from left to right. So these are my points, and we're going to graph this guy. Don't worry about being a perfectionist. That's my job. Now remember what I said about having these lines, but to solve these guys by graphing. You're trying to find the point where they intersect. Well, their intersection point happens to be this guy right here. And those coordinates are, well, let's see, 1, 2, 3, and then down 2. So the ordered pair we have is 3, negative 2. I think if you look here, you can see that 3, negative 2 is on both the purple line and it's on the green line itself. Well, how do we know if this is true? Well, we can check our work. If we say that 3, 2 is the solution, it should work in both of these. Well, if I plug in 3, 2 into my purple line, plug in my 3, plug in negative 2, what do I get? Well, that's 3. Negative times negative is a positive 2. Does this equal 5? Yes, it does. So I know it works in the first guy. Well, let's see about the other one. I have 2 replacing the x, and I'm replacing the y. And I'm going to replace them with 3 and negative 2 respectively. Well, let's see, 2 times 3 is 6. That's just a minus 2. And we see that 6 minus 2 does equal 4. So we can say without a doubt, that the ordered pair 3, -2 is the solution. 3, -2 is the solution because that's where these guys intersect. Okay, right here, 3, -2. Now, graphing is neat because you can see where the lines intersect, but it can also be a headache for us. Because what if we didn't have a nice slope to get these clear points on here? Or what if these lines intersected but we couldn't see them? Like you could have, say these guys were intersecting right here, this line and say this one. Well, we know that eventually these guys would intersect down here, but we're not going to be able to see that from the graph that we have unless we change the window. And don't forget about how sometimes things intersect and they're not always integer values like the 3, -2. They could intersect and be nasty fractions or decimals. And you wouldn't want to try to pick that off from a graph. Well, that's why we have algebraic ways for solving these. That's what we're going to talk about next.